This video will show you equations 3 through 10, the underline and count method. Pause as much as you need to.
So on the left side here in number 3, I see 1AL. Look at this F. How many are there? 2. And then here I see, again, the AL with no subscript, so 1. And then here the F with 3. So when I start on the left, I see 1AL, jump to the other side of the arrow, 1AL. Those match so far, those are equal. But the F's are a problem. We have 2 on this side and 3 on this side. So I have to make them more. So if I start with the one that is less, the 2, and I try putting a 2 there, I'll see that gets to 4. But 3 cannot ever be multiplied by something to get to 4. So I need to think again. I'm going to erase this and kind of start over on this one. Now here's a trick. Like with fractions, a common denominator for 2 and 3 is 6. So when you have 2, trying to balance a 2 against a 3 on the other side, you might have to go to 6 or even higher. But in this case, I think 6 might work. So what would I multiply and put here? Multiply by 2 to get to 6. What times 2 equals 6? And so I'm thinking, 3 times 2 is 6. So I'm going to show below my total now. And on the other side, to make that one 6, I need to think, what times 3 equals 6? Well, 2 times 3 equals 6. So I need a 2 here. And that, now I'm going to show below, and remember that affects the whole molecule. So 2 times 1 for the AL is 2, and 2 times 3 is 6. So now my F's are good. Now I go back and realize, oh, but I only had 1 AL. So to make this work, I'm going to need to make that balance against the 2 total I have now over here. And so I will add a coefficient in front of this AL on the left to make that balance the AL on the right. So I'm going to put a 2 in front, and I like to show below, so I'll go 2 times 1, 2 times 1 is 2. So my totals are below, but those coefficients are what we need to see. Let's do the next one. Underline and count. 2, 2, 1, 1. So on the left side I have 2 H2s, and on the right side I only have 2 H's on the left and 1 H on the right, the totals. On the left I have 2 Cl's and 1 on the right. So the side that has too little, the ones, I'm going to have to multiply to make higher. So if I put a big 2 in front on this right side over here, I'm going to put a big 2 in front, and then that will multiply both of these, which is perfect because I needed them both to multiply. So that one looks good. Let's double check. We have 2 on the left, 2 H's, 2 Cl's on the left, 2 H's, and 2 Cl's on the right. Okay, let's try the next one. 1 Xe and 6F on the left. 1 Xe and 2F on the right. So my Xe's are equal, so let's look at the F. 6 on the left and only 2 on the right. The one that is too little is where I have to multiply to make it more. So if I want it to equal 6, can I multiply something by 2 to get 6? Yes. I can multiply a 3 here times the 2 is 6. So my totals on the right side are 6 F's. Let's double check. We have 1 Xe, 1 Xe, 6F, 6F. That's balanced. The next one. Underline and count. 1 Ag, 2H, 1s, 2ag, 1s, 2h. Let's check what's balanced and what's not. On this side, on the left, I have 1ag. Jump over the arrow. On the right, I have 2ag. Before I fix that, I'm going to just kind of look ahead at everything else. On the left, I have 2h, and on the right, I have 2h. That's good. On the left, I have 1s, and on the right, I have 1s. So everything's good except that ag. So the one that has too little is where I'm going to multiply. On this side, I had 1 ag, and on the other side, I had 2. So this side that I circled is less. So what do I multiply by 1 to get 2? And that's easy. We'll put a big 2 in front, and that's going to change the total on the left side so that it matches and it's equal to the total on the right. Remember to keep pausing and trying on your own each time, and just watch me if you need to. All right, on number 7, I'm underlining and counting. It's a capital N and a capital O, so there's one N and one O, and on the other side I have 2N and 2O. So it looks like on the left side I have less N and O, and so that's the side over here that I'm going to need to add a coefficient to multiply that one and make it equal the one on the right, the ones on the right. So I'm going to put a big 2 in front here because 2 times 1 is 2, 2 times 1 is 2, and now it looks like everything's balanced. 2n on the left, 2n on the right, 2o on the left, 2o on the right. Remember, thinking about drawing the pictures or using Legos might help you to understand what all these symbols mean. But try to think about that so you know what's going on here. On the left side now, number 8. 1 Fe, 1 O, 1 C, 1 Fe, 1 C, 2 O. And so I'm going to look on the left, I see 1 Fe, on the right 1 Fe, on the left 1 O, on the right 2 O. And then I have on the left 1 C and on the right 1 C. So I'm going to need to put a number in front of the one that's too little. On the left I see 1 O. Now I don't really want to change the Fe, but I don't really have a choice. So I'm going to put a big 2 in front, and I'm going to multiply both because that coefficient multiplies the whole thing. So that made my O's balance. And now I got to double check my Fe's. So there's 2 Fe on the left now and only 1 on the right. But that's okay. I'll just put a 2 in front here. And now we're good. Okay, 2 more to show you. And then on problem set B, you can try on your own. So I have 1 Si, 2 O, 1 C, jump over, 1 Si, 1 C, ooh, another C here, and 1 O. So this one is a little bit different in that on the right side here, we see we have a C on each of these molecules, so our total on the right side is actually 2. And so if I count 1 Si, 1 Si, that's balanced. 2 O, and over here only 1 O. And so on the side that I need more of is where I got to put a coefficient. So over here on the right side with 1 O, I'm going to put a big 2 in front, and then I'm going to show below that multiplies both. So I'm going to show below 2 times 1 for this C is 2, and 2 times 1 for the O is 2. And now that changed, oops, what's that? That changed the total here that I just wrote to show where we have 2 C's now and 1 on the other molecule, so there's actually 3. on the right side. And so now if I look at my C's on the left, there's only one here. So to make these things that are on the right, I'm going to need to start with 3 C's. So I'm going to put a big 3 in front. And that changes the total on the left. So pause and think about that one a little bit. And again, what makes that tricky is the 2 C's in 2 different molecules, but they're both on the right side of the arrow. So we're counting the totals, remember. Okay, last one for the video. 1 Mg, 1 H, 1 Cl, 1 Mg, 2 Cl, 2 H. So it looks like on the left side I have 1 Mg and on the right side 1 Mg, so that's balanced for now. But on the left I only have 1 H and on the right I have 2. So I'm going to, the one that's too little, on the left side here, I need more, so I'm going to multiply that. If I put a big 2 in front, that will change it to 2H and 2Cl. And now I'm going to check my Cl's on the right, and those are also 2. So that worked out perfectly. Double check 1 Mg on the left, 1 on the right, 2 H's on the left, 2 on the right, 2 Cl's on the left, 2 on the right. It is balanced. All right, you got this. Remember, you can come to Google Meets if you need help.